Lesson 105, mental math answers. Here we go. This is going to be a positive because we have 4 negatives multiplied together. And what I do is do 2 times 2, which was 4 squared, and you double that. So like 4 times 4 is how I do this one in my head. This one, here's step 1, just showing it for you. 4 times 4 is 16, and then 10 to the negative 4 times 10 to the negative 4, we get negative 8. So we basically add negative 4 plus negative 4. We get negative 8. And that's not proper form, so that 16 is the same as 1.6 times 10 to the 1. So positive 1 plus negative 8 is negative 7. All right, this one, what I do in my mind is go add these like terms, 5w. So if we have 5 w's equals 60, so w must be 12. All right, this one kind of stumped me because I was surprised that they were so close, but I even double checked. So if we take 9/5 of 35, we get 63, negative 63. Add 32 to that, and we get negative 31 degrees Fahrenheit. All right, 200% of 50. Well, 100% of 50 is 50, so we double that to get 200%, so that's 100. 100% more than 50 is first, what is 100% of 50 is 50. So you add that to 50 and we get 100 as well. Okay, same answers on that. And now we're going to talk about surface area. Surface area takes a lot of time to calculate, but it's not necessarily difficult. It just, you have to be willing to write down a lot of things and add them all up. Okay, so the total area is, surface area, is when we take the area of all the sides and add them up. This three-dimensional block here, which we call this a rectangular solid, or a rectangular prism, or a box. Okay, so there are 6 sides to this thing. And if we want to find the surface area, we have to take the area of each of those 6 sides and add them up. Now what we did here was piece them out. This is the rectangle, which is the front and back. So do you see the front and back are going to be the same shape, and it's a 6 by 5 high. Okay, so there are 2 of those, right? So if I were to find the area of that, it's length times width. We have 5 times 6, and we get 30. And then we actually have 2 front and backs, so we have 60, right? So we could, if you were to make a chart here and they do this, area of front and back equals 30 plus 30 equals 60. And this, they do a chart, kind of a chart in the book, a list, okay? Centimeters squared. So we've got 2 of our 6 sides, right? Now the sides, which is this and then the other one here, are 3 by 5, right? 15. The area is 15. So I'm just writing this to show us, okay? And there are 2 of those. So area of the sides equals 15 times 2 equals 30 centimeters squared. So now we've got 4 of the 6 sides calculated of the areas. So the top and bottom are the last 2. And the top and bottom is a 6 and it's a by 3. So sometimes it's not written exactly where you need to see, but this rectangle is a 6 by 3. So area equals 6 by 3, and so that's 18, okay? So area of, let's say top and bottom equals 18 times 2, which is 36 centimeters squared. Now surface area, you get all those, and then you have to add them all together to get your total surface area, okay? And so that would be 90 plus 36, which is 126 centimeters squared. So that's how we get the surface area of a shape, okay? You add up all the sides. Now notice, notice this one is a triangular prism, okay? So we're going to find the surface area of that. Now notice that the surface area of a triangular prism is made up of rectangles and 2 triangles. So we have 1, 2, 3 rectangles and 2 triangles. All right, so there's actually 5 sides, 5 faces that we need to add up. Okay, so what I might do is first take the triangle and find the area of the triangle is 1/2 base times height, and our base is 3 and our height is 4. So area of one of the triangles is 12 divided by 2 is 6. And we have centimeters squared. So that's one of the triangles, and there's 2. So the area of the, let's call it the ends, are 6 times 2, 12 centimeters squared. Now we have 3 uniquely different sized rectangles to find the rest of our faces, okay? So let's take this rectangle first, okay? This big one on the front that we see. So we're going to say area equals length times width, and it's a 6. And if that is 6, do we know what that is? That one is, yeah, I made a mistake here. The actual picture, this is 5. I left it out. So go ahead and draw in that dimension, okay? So the area of this first big rectangle is 6 by 5, which is 30 centimeters squared. Okay, so now we have 2 more. We have the area of, let's call it the bottom, is length times width. The area of the bottom is a 3 by 6, which is 18 centimeters squared. And then the area of the back, how about that, is a 4 by 6, which is 24 centimeters squared. So yes, these are going to bug you because look at all this calculation we have to do. But it's not complicated. It's just you have to be organized to keep track and make sure. We have 5 faces on this. Do I have 5 areas? 1, 2, 3, and then 2 of these, 4, 5. And now I add all those up. We've got 12, 30, 18, and 24. And that will give us our total surface area, right? And when we add all those up, we should get 84 centimeters squared is our total surface area. All right, so you want to write nice and neat so you can see your work and stay organized. Okay, example 2, same ideas. Now though we have circles. This is actually harder for people to remember in finding the surface area of a cylinder, okay? Well, because how many sides do we really have? We have a top and bottom, and then we have this big curved piece, okay? So what I want you to do is notice if this was a soup can, okay, you've got the circle on top, the circle on the bottom, and then we have a label, right? If we had a label that perfectly matched up, it is the shape of a rectangle, isn't it? So this curved side, if you will, is actually has the dimensions of a rectangle. So in order to get the surface area of a cylinder, we take the area of the top and bottom, which is doubling pi r squared. Remember, the area of the top circle is pi r squared, and there's 2 of those. And then we add the rectangle. Now the rectangle is the height that they give us, and where did they get 2 pi r? What's this? If you unwrapped a soup label, what is the length of this? Well, because it wraps perfectly around your circle, this length here is the circumference of your circle, because it wrapped perfectly around. Say here, I don't know if you can see this, it's too big of a paper, but if this was my soup label, let's see, here's my soup label, see that circle, the circumference of this is the length of the rectangle, okay? So that's how we find it. Now let's go ahead and try finding first the area of the soup label on this can, okay? And that's, again, if we unwrap it, it looks like this. So if we do that, our soup label has a height of 10 centimeters, right? We're going to just put it in right there. We're going to use this. So that's 10. And 2 pi r, well, our radius is not 7, is it? Our radius is 7/2. It's half of 7. So our radius is 7/2. Or we could say 3.5, but let's keep it in fractions since they kind of are leading us to use fractions. So area, again, let's do it this way, equals length times width. All right, I want you to write this down. Our length is the circumference of our soup can, and our circumference is 2 pi r, right? And our width is the height. So now we're going to plug in what we know. 2, and then it says use 22/7 for pi. And our radius is 7/2. And our height is 10. So those are all the numbers we need to find the area of that soup label, okay? And now we just calculate that through, and they were really nice because they gave us fractions that will cancel out. So the 7 here and here will cancel out. And then these 2's will also cancel out, right? So we virtually have left just 22 times 10, okay, which is 220. And we've got centimeters squared, okay? So that's how we get part of the surface area. Part B, they want us to find the total surface area. So we have to take the label and add it to the area of the circle on top and the circle on the bottom. So let's do that. Let's find area equals pi r squared, okay? And like they said, use 22/7, so that should be a squiggle because we're now rounding. 22/7 times radius squared, which was 7/2 squared, okay? And that reduces or simplifies to 49/4. 7/2 squared means 7 times 7 over 2 times 2, which is 49/4. Okay, now we can start canceling stuff out. 7 goes into 49 7 times, so that was nice. And 4 doesn't go into 22, but 2 does, and so we get that. So now it looks like we have 77/2, okay, centimeters squared. So now that's the top and bottom. No, sorry, that's the top. But we have 2 of those, right? So our total surface area is about 220, that's the label, plus 2 of these, right? So I'm going to do this. 2 of the circles. And so that simplifies to 220 plus 77, which is, sorry, I got about 297 centimeters squared. I was looking in the book, so I got distracted. There we go. Okay. Not necessarily complicated, but very hard to keep track of organizationally. And understanding how to, we call this the lateral surface area. The label is the lateral surface area. Okay, so now we have another formula, and I have a picture, we have a picture of an orange or a lemon here. Okay, and we're talking about spheres, okay, a circle, a circular three-dimensional object, okay. So in order to calculate the surface area of this, how much area is on the big, it's all around, it's just one big curve, isn't it? We first can calculate the area of the largest cross section. So if you cut an orange in half, the largest circle that you can make by cutting it in half is what we do first. Or this is how they get the surface area of a sphere. Okay, so the surface area of just this circle would be pi r squared, right? And then in order to get the surface area of the whole thing, we multiply it by 4. So the biggest circle times 4, the area of the biggest circle times 4, or we call that a cross, the biggest cross section. Okay, so here is our surface area. This is wrong for those of you who have already printed this out. This should be surface area. of a sphere is 4 pi r squared. Okay, so let's look at example 3 and do this one. Okay, tennis ball has a diameter of about 6. Use the surface area of the tennis ball to find the surface area to the nearest square centimeter. Use 3.14 for pi. Okay, so we're just going to plug in what we know as far as, or we're going to use the equation formula. Okay, so surface area equals 4 pi r squared. Okay, and then what do we know? We have 4, we have 3.14, so again, I need to stop forgetting to do the squiggles. And then the radius, well, the diameter is 6, so the radius is 3 squared. Okay, so when we calculate that through, we get 4 times 3.14 times 9, and that's 36 times 3.14, and I will go ahead and just let you know that's 113 and 4/100ths, and we get that. So we just use that formula and plug in. Okay, now the perfect square, now we're going to talk about something totally different, no more areas and volume, or areas. The perfect square, 25, has both positive and negative square roots, meaning something times something equals 25, and they have to be the same. So yes, 5 times 5 equals 25, but there's one more that also works, and that would be a negative 5 times a negative 5. So since we know those both are true, we can say the solution, if we had x squared equals 25, this has two solutions. X can either be 5, because 5 times 5 is 25, or x can be negative 5. So we would say this. It has two solutions, 5 or negative 5. Another way they do it is this. The answer is plus or minus 5. Okay, so you'll see that, plus or minus. That means two different numbers, and it's just a shortcut. Okay, so now what are the square roots of 5 on example 4 here? What are the square roots of 5? Now 5 is not a perfect square. So what we would say then, or what are the two square? Yeah, we would say one of them is the square root of 5, and the other one is the negative square root of 5, is how we do that when they're not a perfect square. So if they ask what are the square roots of something that's not a perfect square, you write it this way, under a radical sign, plus or minus. Okay, now what about this idea? Cube root of 64. What that means is what number times itself 3 times equals 64. All right, and you might be thinking, oh, I don't know. So let me help you. 4 times 4 times 4 equals 64. Okay, 4 times 4 is 16. 16 times 4 is 64. Now, is that the only answer? Is the cube root of 64 4? Or could it be negative? Let's think about that. Could negative work? If we did negative, we have 3 negatives, and that would be a negative 64. So no, that's not going to work. It only has one possible answer, and that is a positive 4. Okay, so let's try some of these. Okay, now what number times itself 3 times is 1,000? And yes, you're probably thinking, oh, 10 times 10 times 10. And I'll show you. You don't need to write this. 10 times 10 times 10 equals 1,000. So the cube root of 1,000 is 10. Okay, now this one has a negative under there. What number times itself 3 times equals negative 27? Okay, so this is kind of like using training wheels just to get used to it, but you'll start memorizing these. Okay, so how about 3 times 3 times 3? Now that equals positive 27. So in order to get negative 27, all these 3's have to be negative. So the cube root of negative 27 is negative 3. There we go. There's the answer, circled. Okay, now it's practice. I know this was slightly a longer lesson because I had two completely different skills that they taught. So, and these take a while with surface area. So if you want to go ahead and do it on your own and come back and check, that's great, or use the answer key. But I do want to see all your work, okay? All right, so we're going to find the surface area of this. So I'm going to find 3 surface areas, double each one of them, and add them together because we have top and bottom, front and back side, and our sides. So I'm going to say the area of the sides is, it looks like I have a 4 by 4. So 4 by 4, which is 16. Okay, multiply that by 2 and I get 32. So we kind of do this in a list. Okay, area of the top equals 10 by 4, which is 40. Multiply that by 2 because I also have a bottom, and I get 80. Okay, so we've got the sides, top and bottom, and we'll say the area, area of the front. Area of the front is a 4 by 10 also. Okay, so it looks like the front and the tops were the same. Okay, I'm just double checking. 40 times 2, and we get 80. Add all those up, and that's our surface area. So we've got 192 meters squared, because we're dealing with 2 dimensions, just the surface, the faces, right? All right, there we go. Letter B, find the surface area of the triangular prism. So again, we have 2 triangles and 3 rectangles, right? Okay, so I'm going to find the area of the triangles. I don't know why I did the parenthesis there. So area, base times height equals 1/2 6 by 8, and we have 24. Okay, so that's the area of one of the triangles. But I'm going to say this, 24 times 2, because we're going to do an adding up here on the side. All right, so double those triangles, we got 48. Now we've got maybe the area of the bottom, and that's a 6 by 10, and so that's 60, and I'm going to write that right there under the triangles. And now we have, let's do area of the back, and that is an 8 by 10, which is 80. So I'm going to go ahead and put that in my list. And now we just have, we'll do area of the front, which is a 10 by 10, which is 100. Add up. Now do I have all 5 sides? 1, 2, 3, 4, 5. Yes, and we add all those up. We get 8. 288 inches squared. Okay, so now then I would probably say that the cylinders are the harder ones because we've got labels, tops and bottoms. So they separated out, find the area of the label, okay? Now remember, the area of the label, if we took this rectangle, took the label off, it looks like that, right? And, sorry, I'm having trouble. There we go. And this is 4 centimeters, right? And this is the circumference of your can, which is always 2 pi r. So if we took 2 pi r times 4, we're going to have the area of the label. So area equals, I'm having trouble getting my camera in the right spot. There we go. 2 pi r times 4. All right, and then we're going to use 3.14 for pi. Our radius here is, oh, there it is, 5. Okay, and then times 4. So I'm going to deal with these numbers first. 2 times 5 is 10, so we got 40 times 3.14. Okay, and I'm going to just pause and go off. So 40 times 3.14, I get 125.6, and so the label is about 125.6. Now we're going to add that to the top and bottom to get the total surface area. So let's get the area of the top and bottom. I'm going to say this, the area equals I'm going to put a 2 out in front. That means we're doubling the area of the top and bottom. So pi r squared, but doubling it. So that equals 2 times 3.14 times 5 squared, okay? Which is 25 times 2, which is 50 times 3.14. Okay, so I did 50 times 3.14 and I got 157 centimeters squared. Now we add that to 125. Maybe I'll do it over here just to show you. And we get 282 centimeters squared. Okay. Okay, letter E, the diameter of a golf ball is about 4 centimeters. Find the surface area. So we're going to use the formula surface area equals 4 times, pi times radius squared. So we're going to do 4 times 3.14, and the radius is 2, so we can say 2 squared already, or 4. So that actually simplifies to 4 times 4, which is 16 times 3.14. And we're going to do that. Often we do that, I get 50.24, but let's go back and it says to the nearest square centimeter. So that rounds to 50. So it's about 50 square centimeters. Okay, what are the 2 roots of 16? Square root of 16 equals plus or minus 4. Okay, now if we do 5 times itself 3 times, we get 125. Okay, what times itself 3 times is negative 8, and that would be negative 2. And there we have. I know it was a long lesson, but surface area is never quick. So I'm just showing you that there is no shortcuts. So you do have to take your time.